Welcome everyone to the course of Mechanical Unit Operation. This course is being conducted on NPTEL from Professor Nanda Kishore, who belongs to IIT Guwahati. We discuss about the course, what is the schedule of the course, and what is the content of the course. Then we also discuss why this course is required to understand the most of the industrial mechanical operations of chemical engineering. We also visit some basic examples which requires your physics knowledge and little bit knowledge from your other courses like fluid mechanics and all. So let's start the beginning of doing this, enjoying this course, and let's go. So here we start with mechanical unit operation. You can see the screen, right? So this is the home page of this course. As you can see, mechanical unit operation by Professor Nanda Kishore. And course duration is it is for the 12-week course. The start date of course is 25th of July 2022 and end date it is 14 October 2022. Exam of this course will be conducted on 30 October 2022. Okay. Now I want to give brief introduction of our instructor. Instructor of this course is Professor Nanda Kishore. He is a professor from IIT Guwahati. He completed his PhD from IIT Kanpur in 2008. He was a Brunel Research Fellow after his PhD at School of Engineering Sciences, University of Southampton, UK. He was also visiting researcher at University of Surrey, United Kingdom. He received many awards. Some awards are Young Scientist Research Award, IEI Young Engineer Award for the year 2015, Young Scientist Research Grant from Science and Engineering Research Board of Department of Science and Technology. And he is very keen to teach the mechanical unit operation course. And he is taking this course since quite some past sessions. And little bit my introduction. I am Bhavik Kumar Mahant. I completed my BE from Gujarat Technological University in 2017. I have a degree of diploma in rubber engineering from Indian Rubber Institute and IIT Kharagpur. I have small industrial career as an executive process engineer in UPL Limited. After that, I joined IIT Madras as a MS scholar, then converted into the MS and PhD in February 2022, and I got Prime Minister Research Fellowship after 1 year of converting into the PhD. This is all about the brief introduction of teacher as well as myself. Now, the major question of all NPTEL courses was about the course certification. So you need to understand that learning is always free on the platform of NPTEL. But if you want to enhance your skill by taking the certification of the particular course, then you need to give an exam. An exam is optional and it has a fee of 1000 rupees. For this particular course of mechanical unit operation, the exam will be scheduled on 30 October 2022 and there are two sessions, morning 9 to 12 a.m., 9 a.m. to 12 p.m. and afternoon session 2 p.m. to 5 p.m. And if you talk about the criteria for getting the certificate of this course, then it is an average assignment score of 25% will be considered. Total 12 assignments are there. Best as 8 assignment will be considered for the average out the course score. Other final exam has 75% of weightage, and our final score will be based on average assignment score plus exam score. Okay, so if there is a one particular criteria, if you are only eligible for certificate if average assignment score is greater than or equal to 10 out of 25 and exam score is greater than or equal to 30 out of 75. Any of criteria is not met, then you will not get the certificate. Even if you have like something you have 50 out of 75 in final exam, but you don't have 10 marks in your average assignment. Assignment score average is not 10, then also you will not get the certificate. Now, outline of course. This course is very interesting and very fundamental in its nature. You all come across the topic of this course uh, past also. So first we will start from the introduction of particular sizes and shapes. So you can understand in industry every time different size matters for different kind of operation. So at the end you understand that chemical engineering is everywhere. But if you want to make a big car paint varnish, and you if you want to make some little small artificial heart from polymer material, then everywhere the size will be different. So you need to understand that particulate size and shapes are most important in chemical engineering. Other is the screening. How can you differentiate the screen size, particle size and shape with the help of screening? This is a basic operation. Then size reduction instruments are there. Why we are using this size reduction crusher, roller, and different kind of instrument? Main thing is that whenever we are getting some metal ore or something, it is in a huge amount, in a bulky nature. So we need to reduce its size for proper use. So all the natural sources have a different size. So we have to use the size reduction equipment over there. Now storage and conveying of bulk solids. We need to, after size reduction, we need to store it and convey it to from one place to another. For that, there are different methods are there. Size enlargement is the another topic. Sometimes you requires to be enlargement of size by agglomeration and different methods. We will learn in this particular size enlargement section. Flow past blob bodies. So whenever any kind of liquid and gas flow will be passed from the blood flow is different kind of interactions between the bodies and the flow pattern will be there. We will discuss this. Then flow through packed and fluidized bed. So packed bed and fluidized bed are very important in advanced processes. So we need to understand how to design those in equipment and what are the process parameter we need to we need to consider while designing. Filtration is always any liquid component is present in any of the process. Filtration is the way to separate it out solid particles and some impurities from that liquid. Cross flow filtration and membrane separation. In filtration, if we go much more deeper, then cross flow filtration is one of the advanced process, and membrane separation is the another. So this kind of process will require to separate it out the solid other impurities and different kind of materials from each other. Then gravity sedimentation process. Most of you heard about this or maybe saw videos about the wastewater treatment. So many of the wastewater treatment process require this gravity sedimentation. Centrifugal separations. So centrifugal represent on the basis of mass of the materials. We give them the centrifugal force and we can easily separate out the two different materials. Flotation. So in our high school science, we learn flotation process. So this kind of different flotation process is also required sometimes in order to generate the pure product. Now, what are the books? So there are basically three different books uh, which were suggested from the professor. So most first is the Unit Operation of Particulate Solid by E. Ortega Rivas. You can use that. And very popular book of the chemical engineering that W.L. McCabe and James Smith, which is known as a Unit Operation of Chemical Engineering. You can use that book. That is a very important book as per this subject. And if you want to go in much detail, then there is a book by Coulson and Richardson, which is Coulson and Richardson's Chemical Engineering second volume, fifth edition. You can also consider that book if you want to go in much detail to design various different unit operation. Now, we start with the basic examples as a part of the practice of the course. So you can understand after this visiting these different examples that this kind of example you already take care of it when you are in the high school in the physics subject. Basic physics and sometimes fluid mechanics laws are applied. So this is the first question. In a column of liquid if two glass beads of size 10 mm and 20 mm are settling individually, which of the following statement holds correct? So as you can understand here, it is mentioned about the column. So there is, as you can see, there is one column like this, and in that one 10 mm particle and one 20 mm particle is there. Both are freely settled. Settling means you have to drop them freely, and according to the mass of the particle and different forces acting on it, it will settle down at the bottom. So what is maybe the answer? There are four options. One is 10 mm size grass bead settle faster than 20 mm. Other is a vice versa. C is the boat has the same velocity, and D none of the above. We can see that it's a basic settling velocity and or Stokes law. Stokes law, the famous experiment which all perform in our physics. So that the same law will be useful over here. So we use the concept of physics, as I told you, that the force of viscosity on a small sphere moving through a viscous fluid is given by Sir George Stokes. So he is a famous physicist in ancient time. He gave one very good law, and then that was also modified using some Newton's drag law, and many things are you already maybe learned in your physics. So as you can see, whenever any particle is freely settled in any of the cylinder or column or somewhere, there are mainly three forces which are acting. One is a gravitational force. Always gravitational force acting everywhere. So depending on the mass of the particle, this is m into g. So m can be converted into the volume into density into g. Other is the buoyant force. So buoyancy force is always it is also a famous force when you are any liquid, if you are trying to put any weight and of any particle, liquid also exerts some buoyancy force on it. And the final and important force is the drag force. So whenever any particle is going down, there is some drag force on the opposite direction, it will be there. Okay. So what is the equation? You might be remember this equation. This is equation comes from the Stokes law, and there is small uh, mathematical arrangement you have to perform. At the end, you will get this terminal velocity of sphere falling in a fluid equation. V is equal to d square z rho p minus os upon at eta. So most probably, I think everyone knows this equation. G is the gravitational field strength, D is the diameter of particle, rho p, rho f is the density of particle and fluid, and eta is the dynamic viscosity, or mu and eta. So as you can see here, d square is V directly proportional to d square. So and here we have the diameter of particles are 20 mm and 20 mm. So definitely 20 mm the particle has a higher velocity than the 10 mm particles. So that's why we can say that 20 mm particle has been settled faster than the 10 mm size plasmid. So this is a small simple example. I think you all understand this. Okay, so this is the first. This kind of example you need to solve before the course. I think you are not require any course knowledge to solve these kind of equations, but you need to understand. Okay, what is the exact condition is given in our problem, so we can solve according to it. Now this is another important and simple questions like consider a spherical particles settling in a column filled with water. Which of the following forces act on the particle? As I already mentioned, whenever any settling of particle experiment is performed, so there is gravitational force is there is drag force, and there is a buoyancy force or buoyant force. Sorry. So these three forces are always there. So the answer will be all three. The same thing as you can see here, any particle has drag force, buoyancy force, and gravitational force. We already visit all the formula also in our previous example. So as by using this simple technique, you can understand that three different forces are act whenever this any kind of settling of particle can take place. Now, answer is all about the three forces. Now consider a spherical particle of size 1 meter having a density of 1500 kilogram per meter cube is settling in a fluid due to gravity. What is the magnitude of gravitational force? Now we only need to consider the gravitational force here. Okay, so this is the same figure as we see in gravitational force. Force of gravitation is equal to mass into gravitational constant. So mass is again divided into volume 4 pi r cube density. So it is a mass and this is a g. So everything I think will be given. So for 1 meter diameter, d is equal to 1 meter. So r is equal to 0.5 meter. Now if we substitute all the value, pi r is 0.5 into 3 pi meter cube not 3 1500 kilogram per meter cube into G is 9.81. If you solve this and at the end you will get this 7.705 kilonewton. So you can check that it is there in the answer. Okay. So this is how you solve this different simple kind of example. So answer is C 7.705 kilonewton. Now again, very easy example. Consider a spherical particle settling in a column of unbounded liquid of viscosity mu and density rho. You understand how they explain the whole problem to you. So it's maybe question is very easy, but you need to understand why they are mentioning like that. Spherical particle which has diameter dp settling in a column of unbounded liquid of viscosity mu and density rho. So liquid is not bounded, it is unbounded. You need to understand that those facts. So depending on if you go into much detail, then you can understand why the Reynolds number has this kind of formula and the not other formula, which has a viscosity of mu and density rho. If the settling velocity is ut, always we mention the settling velocity is like u and in the subscript t. So the same thing, this is a settling velocity. So all everything is there. So you know that Reynolds number. What is Reynolds number? It is giving that the type of it is the indication of the flow pattern. That what is the type of flow which we are dealing with. It is whether is it a laminar, it is turbulent, or it is in between the transition from laminar to turbulent. So this is the Reynolds number. And the physical significance, we all understand that inertia force, this is very common for us. We all know these things. Divided by viscous force. And if we substitute both the forces, at the end we will get density into velocity into diameter divided by dynamic viscosity. And as you can see in this figure, Reynolds number can be useful in order to understand the flow pattern, whether it is laminar or it is turbulent. Laminar, it's a streamline flow, which is highly uh, not practical, I can say. It's not highly imaginary. Every time there must be some turbulence is there. So as you can see here, relation also Reynolds number increasing that with the help of if velocity is increased, Reynolds number is also increased because directly proportional. Characteristic dimension like diameter, radius will increase, then also Reynolds number increased. With density, Reynolds number increase, but with the help viscosity, it is not increased. Now here we have rho, we have settling velocity Vt, we have diameter dp, and viscosity mu. So I think our answer is rho into Vt into dP divided by mu. So it is there in the first option. So first option will be our answer. So why we are visiting this kind of very easy example? Because it is required. Sometimes we are not remember each and everything which we already taught, which are already being learned in our high school physics or sometime in the first and second year of engineering. So sometimes it is required to little phrase up before the starting of the course, because in between the course if someone is asking about the settling velocity and you need to use that velocity equation or value in your different kind of, let's say, filtration and other unit operation, you need to understand why it is there and how it is important in order to understand our whole current concept. Now there is one more example. We are also visiting this. This is consider the circular motion of a fluid element in a rotating ball due to which centrifugal force is developed. What is the relation between tangential velocity, which is we all know that which has a unit of meter per second, and angular velocity, which is omega in radian per second. If r is the radial distance from the center of rotation. So we all know that centrifugal force, as you can see here, in centrifugal force, if someone is has something in his hand, like you can consider the stone, which is also noted down with string, and if it rotates among around himself or herself, then there two kind of forces are there. Centrifugal force, which is acting to for on the particle in the direction of uh, away from the person, and centripetal force towards the direction of the person, and this is its path of the inertia which it follows. So every time there is always equilibrium between centrifugal force and centripetal force. So force is this force can be calculated with the help of mass into v square by r. Now here, as we understand from this figure also, we can say that whenever we are using any kind of centrifugal motion, so if this is the path of the motion and any particular point, if you consider this point, then the radius of this point from this radius of this point from the center is r, if you consider it r, and then if we take the tangential velocity, which is known as a vr, so at the end, at the end, this is we known as omega. Think maybe you this is omega. Omega is what? Omega is angular velocity. It depends on the angle between the radius as well as tangential velocity. So if you want to measure at any point, if you want to measure the VR, then you require omega into R. You require the R and omega, the product of R and omega in order to understand what is the value of VR. It's a normal law. So it's normal. Yeah. If you form a triangle and if you apply the triangular law, it is very easy. You require this R and omega together. And this is a normal which we denoted as V is equal to R into omega. So our actual answer is B, which is R into omega. Now, what is the friction factor F? Let me remove this first. Okay, what is the friction factor F for a fluid which has density of rho flowing through a pipe at an average velocity v if the shear stress along the pipe wall is tau w? So here they are talking about friction factor. Okay, so friction factor. maybe you are learning, you already have been learnt in your physics on fluid mechanics. If you have gone through that subject, then friction factor term is always there. So it is also denoted as small f, and it depends on tau w, which is a shear stress. So if you remember, then there is one equation which is like F is equal to tau W divided by rho V square by 2. So if you can't able to recollect it now, so it is the definition of friction factor. It mentioned as the ratio defined of wall shear stress to the product of the density and the velocity head is known as a friction factor. But if you have some finding some difficulty to understand how it comes, so we can go for small derivation also. We already learned this derivation, I think, in fluid mechanics. So in that, what we consider? We consider one pipe, cylindrical pipe, and we apply the two different pressure. Let me use a simple. So P at one end, and as if we consider the pressure difference in between this whole pipe is dP, then P plus dP is here. The length of pipe is we consider dl. Small section of the pipe only we consider. Diameter is d, and and we consider the shear stress. Shear stress, as we know, it is on the if flow direction is like this, then in the opposite direction we have shear stress. So what is the relation between this? Now we will prove the relation. So we are just performing the what you can say, the energy balance and sorry, force balance in the in this pipe. Then you will get like P minus P plus dP. So force, so this is a pressure, and pressure is multiplied with area, so it will convert it into the force, is equal to, at the other end we have shear stress, which is also has a unit of uh, pressure, so we also use the area. So this is the equation, if you can able to recollect it now. Hmm. Okay, so this is the equation, and if we can able to solve that equation, you just rearrange the term, then at the end you will get this equation. Okay, it's a very easy. I directly remember that equation, so I am writing like this. So this is that equation, and if you remove it, the common term from this, at the end, sorry, here it's F. Consider F. So at the end, you will get F is equal to tau W or tau rho V squared by 2. So here the answer is there, which is C, F equal to tau W divided by 0.5 rho V square. Instead of V square by 2, they use 0.5. Okay. Now consider a spherical particle is settling in a liquid due to gravity. What is the buoyant force acting on the particle if acceleration due to gravity is g? So for the buoyant force, the equation is very easy. That rho, yeah, here again I use that's the same figure. In that, for the buoyant force, the equation is volume into density into g. So it's like density into g into volume. So how can we put the volume? Here we don't know the value of the volume, but as we know that density is equal to mass by volume, so we can use volume is equal to mass by density. So here I put it rho by P. So this is actually it is available in the answer. Answer A is m by rho P into rho into G. This is the answer for this equation. So this is very easy. example again. And if we talk about the next questions, then you need to consider a fluid subjected to a stress. What is the property of the fluid that give rise to forces that resist the relative movement of adjacent layers of the fluid? When you heard about the fluid and forces in between the adjacent layers of the fluid, like this, these are the different fluid layers, as you can see, and there might be some forces or some resistance of in between these two layers. So what it called? Everyone direct can strike think about the term which we are consider. As you also understand that if the the flow is like this with intensity of that, then the top topmost layer has the highest velocity, then the velocity will be reduced. Why everything can happen? This is a very common funda behind this. It is known as the viscosity. Viscosity is the resistance between the interreal forces or adjacent layer forces, forces in between the adjacent layers of the fluid, or forces in between the interlayer of the fluid. You can tell by any name. So it's a very common questions we all understand. So answer of this question is resistance between the adjacent layer of the fluid. It is known as the resistant force, which is known as a viscosity. And we already discussed about the how we can use viscosity. So this is a Newton's law of viscosity first. We understand that law, and according to that, we use our further calculation to how to calculate viscosity and how the different types of viscosities are present: dynamic viscosity, kinematic viscosity. So answer is viscosity. It's a very common. I don't want to more give more stage on this topic. Now the same thing. What is the units of viscosity? As I lightly mentioned, Newton's law of viscosity. If anyone knows, I don't think that any chemical engineer can forget this law. But anytime if you anyone will ask you, you need to understand, or you need to the impromptu can say that Newton's law of viscosity is tau equal to mu du by dy. Now this is the dynamic viscosity. You need to give the answer of dynamic viscosity unit if you want to find the unit of viscosity. Then mu is equal to tau du by dy. Okay, so this is a common thing. Okay, now tau, if we consider tau, then tau is nothing but, uh, as you can say, it's a force divided by area. So it has unit of Newton by meter square. And then du is equal to meter by second, and y is meter. So it is meter. If you just do the calculation, then m can be cancel it out, Newton second per meter square. But you know that Newton by meter square is also known as a Pascal. Pascal into second. So this can be the final answer, Pascal into second. And many of the students directly remember the formula of this easy entity like density, viscosity, and any which it's with always are handy when we are talking about chemical engineering calculation. So I think I don't require much discussion over the unit of viscosity. So why we are discussing about very easy problems? So these are just here to just help you to refreshing your topics, brushing up your old knowledge of chemical engineering or old knowledge of basic physics, which we are going to use in this mechanical unit operation. Okay, the last question of our today's discussion is, what is the value of density of water at room temperature? So any of time, if you consider standard value, it's around approximately 997 kilogram per meter cube. But we always consider it as a 1000 kilogram per meter cube. This is the easiest questions among the all questions which we discussed today. But as you can understand, the whole mechanical unit operation subject has a different paradigm. We started from the size reduction, screening, that kind of operation, and then we will switch to the some sophisticated operation in where filtration is very important unit operation, which is discussed in the mechanical unit operation. Then we also discuss about the methodology which we are going to use. I again want to just go for that, uh, just look at our the what you can say the syllabus of this course, which is important to understand why this all courses are forces and basic introduction is required. So as you can understand, sorry, I don't want to go like this, but in the hurry. So introduction of particular size and shapes and screening size reduction is the basics of mechanical unit operation. And okay, so thank you everyone for attending this session or watching the recorded version of this session. You understand that mechanical unit operation is required in order to build your career in chemical industry. And so I'm glad that you chose that course, and in future we are again meeting. Till then, happy learning and stay safe. Bye.